What will happen if in the previous problem we also had friction? So let's say that I will add friction here. And let's say that this friction is 10 newtons. Well, what's going to happen is that I should add the force of friction here, which means that if I go to the sum of forces and in the x-axis, I should also include friction, which would be negative right now. That means that in this formula here, I would have that tension minus friction equals m to a, which means that tension minus friction, which is 10, equals 5a. Nothing has changed on the second object. So the two equations I have to solve now to combine are these two. So what I will have now is that I will need to solve for tension. So tension here will be 10 plus 5a, while here 50 minus 5a will be the tension. So as the tensions are equal, that means that 10 plus 5a should equal 50 minus 5a, or else 5a plus 5a equals 50 minus 10, or else the acceleration will be 50 minus 10 over 5 plus 5. Now you can say, all right, so the rest is math. Why do I keep it like that? Because I want to show that according to the formula that we have here, we said that the common acceleration will be the total moving force over the total mass. The total mass remains the same. It's 5 and 5. What changes is now we don't just have the force due to gravity pulling it down. We have a force that opposes the motion, friction. So the total force now, the total moving force, is not the force due to gravity. It's the force due to gravity minus friction. Okay? Friction cancels out the 10 newtons, a part of the force due to gravity. And the remaining is what actually moves the system of objects. So this is the only difference now, that I have two forces. And I can also see it here.